Can you hear me?
Perfectly. Perfectly.
Okay, that's perfect. Let me check it. Can you say something?
1, 2, 3, techno. 1, 2, 3.
It works perfect. Can you hear me?
Yeah, still perfectly.
Okay.
Ah, yeah.
Let me check it. Can you say something?
What?
Okay, we are on YouTube now, and it works.
Great, great.
Okay, so I can start allowing people to joining us. Hello, Georg. Hello, Steingarm. Can you hear us? We have 5 minutes to start.
Ja, macht keine Sache. Zwei Sachen fehlen noch. Gut, dann 21 die Monika. Und 2 Euro noch einmal Trinkgeld beim Bauer. Okay? Alles andere hast du.
Okay. So welcome everyone. Slowly more and more people are joining. So yeah, but okay, so today's presenter, I think, need no introduction, but let me say a few words about our mentor. So he's a trainer, consultant, developer with focusing on Angular, trusted collaborator for Angular, who writes for O'Reilly and German Java magazine and many, many more. Google developer expert, Microsoft MVP, author of many books, active worldwide conference speaker and workshop trainer. Ladies and gentlemen, Manfred Steyer. Manfred, the stage is yours.
Yeah, thanks, Darek. Thanks for having me. This talk today, this webinar, is about Angular's future with signals. And I really do believe that signals have the power of shaping the future of Angular. For this, I've prepared several things. We will start with the motivation behind and the basics of signals. And then we will go on with live coding. Most of the stuff I want to show you will be shown by using live coding, because I really want you to see how signals feel alike. For this, we will migrate an existing application to signals. Then we will talk about the Interop feature between RxJS and signals, and this also leads to interoperability with NGRX. We will go on with an outlook to signal components, a new kind of component coming up in further versions of Angular. We will get signals now with Angular 16 in some weeks. And after Angular 16, we will get eventually signal components, which brings a new API on top of signals, a component-based API on top of signals. And then we will, of course, do a Q&A session. And for this, please prepare your questions. I am happy to answer all your questions. Okay, let's get started with the motivation and the basics. So all starts with change detection in Angular. If we look at change detection in Angular, we see that in the beginning, we have Zone.js. Zone.js is doing something that is somehow special. It is monkey patching all the browser APIs. That means it changes all the browser APIs, like all the HTML elements, like the button and text fields and drop-down fields, like the promise, but also stuff like the XHR object, the XML HTTP request object. And it does this in order to find out when an event handler runs. When event handler runs, Zone.js is triggering Angular. It's informing Angular. It's telling Angular, hey, something happened. And now Angular says, oh, there was an event handler. In theory, such an event handler could have changed all the data displayed on our page, all the data in all the components. Of course, in practice, never ever all the components are changed, but to be on the safe side, Angular assumes, at least in default mode, that everything has been changed. And so everything is checked for changes, all the components in your component tree. This is implemented in a quite smart way. The Angular compiler is emitting code for this, code that can be optimized by the virtual machine in your browser. However, in order to make it a bit faster, there is this on-bush mode. I'm quite sure you know about it. It's about finding out a bit better which component might have been affected by a change. So you can narrow the amount of components you need to check. The thing is, there are several drawbacks that come with Zone.js. The first drawback is Zone.js is magic. That means it works until it stops working. And when it stops working, then you have a bad time, because debugging issues here is really a nightmare. But in most situation, it really works. So normally we don't need to burden ourselves with this. Another thing is Zone.js comes with an overhead of about 100K. Perhaps you say, well, 100K, hey, we are writing business software, 100K doesn't play any role. So why do we discuss about it? And you might be right. However, when we talk about web components built on top of Angular, then 100K matter. Because here we might have the situation that our polyfill Zone.js, which is considered some kind of polyfill in this case, is larger than the bundle of our web component, of our little tiny beautiful datetime picker, for instance. Another thing is that Zone.js can monkey patch all the APIs, but it cannot monkey patch statements like async and await. And that's why even with nowadays Angular, async and await is down-leveled to promise chains. And this is somehow funny, because meanwhile, all the browsers out there supporting Angular also support async and await natively. But nevertheless, we need to down-level it to promises, because promises can be monkey patched by Zone.js. There is some extra code within the CLI telling the bundler to down-level this statement, even though we build bundles for modern browsers. And last but not least, the change detection is quite coarse-grained. That means each component, or to put it another way, components are always checked as a whole. It is not possible to just check a little tiny portion of the component. So let's say here in the bottom right corner, a value changed. Currently, it's not possible to just check this value, to just update this value. Currently, we need to update the whole component. And little tiny technical detail, as Angular always goes top-down currently, also all the parent components need to be marked for check. That means Angular goes top-down, it goes through all the components until it reaches the component that indeed has a little tiny change in the top bottom corner, in the bottom right corner. And yeah, obviously we can do better here. So the big question is now, how do other frameworks deal with those drawbacks? And it turns out that all the modern frameworks like Svelte, Solid, Quick, and so on go with signals. Also, established frameworks like React already go with signals. Vue will get signal support in the course of this year. And in React, rumor says that the new compiler will introduce something like signals underneath the covers. So seems to be a topic. So how is Angular solving this issue? While also with signals. Now the question is, how does signal-based Angular look like? For this, let's start with a little tiny overview. First of all, what is a signal? Well, a signal can be seen as an object holding a value. Holding a value like this number here. Could also be a string or an object or an array. And obviously, a consumer can read this value. In this case, the signal becomes the producer in this relationship. Also, everyone else can change the value. So in this sense, it's like a typical variable. However, the nice thing comes now, because it's possible to notify consumer in a very lightweight way so that they know, okay, my data has been changed. If we don't go with signals in Angular, then you might just go with ordinary types, like here we have a flight array. Here we are loading this flight array from the backend. And here we are data binding it. A very simple example for Angular. If you go with signal, this looks almost the same. However, everything you want to data bind is wrapped into a signal. And this is done with this helper function called signal. The helper function that gets the initial value. And when it's not possible to infer the type of this initial value, then we need to go with this type parameter. Very often, the type can be inferred, not with an empty array, because the empty array doesn't tell us about the objects that are allowed to be put into the array. That's why we need the type parameter. Then we can load data, and then we need to set the value of the signal. We cannot use the equal sign. We have to go with the setter function or setter method, because a signal is an object holding a value. And when reading the value, we need to go with a getter. For this, we just use the signal as a function. Parentheses, parentheses. That's it. And yeah, perhaps you have heard the rumor that you should not go with functions in the template. This is a general purpose recommendation, and quite often this recommendation is true. However, here in this case, it's really fine to go with a function, because here this function is not doing a lot. It is just returning the current value, and it informs us when the value has changed. So it's not a big deal, and so it's totally fine to go with this function. It's like a getter in this case. Okay, so much for the theory. As promised, I want to show you a lot of additional stuff by using a demonstration. For this, let's have a look into this example here. This example I'm using today is a version of my flight application. It's a very simple application. I really like to use it for training purposes, because it's as simple as possible and as complex as needed to show a lot of concepts in the world of Angular. It's about searching for flights like Hamburg-Graz. If we are lucky, we even find some flights like here. Let's have a look into the source code. If we look into the source code, we see an ordinary Angular component, ordinary properties. And now let's migrate these to signals. For this, let's go with the function signal. Let's import it. Also here. And also there. So when we now look at the type of this variable, of this property, we see, well, there is a writable signal of string. String, the type parameter, has been inferred by the default value. And besides this, it's not just a regular signal, it's a writable signal. That means we have a setter. We can change the value. And this already shows there are two levels of abstraction. There is the normal signal, and then there is the writable signal. This allows us to do some kind of information hiding, where the owner of the signal is a right to read and write it, and the consumer is only allowed to read it. For this, we might cast it into signal. There is even a convenience function that converts it to a signal. When we talk about the array, we need the type parameter. We've already discussed this. And when it comes to the record, we also need the type parameter. But I think that's fine. Okay, so all my properties have been migrated to signals. Now let's go on with the methods. Here I'm validating from and to, and for this I need to go with the getter. Here I'm searching using from and to. That means also here we need the getter. And when writing the received flights back to our signal, we need, you are right, the setter. Okay. Also for delay, we need to respect that we don't have ordinary properties. No, now we have signals that wraps our values. For this, I need to unwrap here. My flights could look a bit like this. Yeah, it almost looks like ASCII art, isn't it? Like the green turtle in Super Mario. And somehow I like the turtle, but I don't like this syntax here. That's why I would prefer to do this in 2 steps. Let's unwrap our signal and then let's use it. Also, we are not allowed to write something back into the signal. However, we could go with the setter. And besides using the setter we've already used above here, we could use a convenience function called mutate. Mutate just gets the contents of the signal, and then it allows us to mutate it. And I really like to wrap this into curly braces. I think this looks a bit more self-explaining. It shows us that the content is mutated that way. Okay, cool. My component has been updated. Now let's proceed with the template. Let's go into the HTML. And the first thing we need to know now is that currently ng model is not supporting signals. This is music of the future. I think the Angular team will look into the forms modules at some later point in time. I think now or in the next releases, it's really necessary because meanwhile we have standalone components and also standalone directives and standalone pipes. And now we have signals. So obviously now is the perfect time to revisit the form modules and to update them. Until this happens, we need to use ng model and ng model change separately. From gives us the value, and from set is setting the value that is found in $event. You know, with ng model change, you find the changed value, the new value here in $event. Don't worry about these squiggles. This is just because I have the current version of the Angular language service installed. I'm going with Angular 16 release candidate 1, but nevertheless, I have installed the support for Angular 15 in my IDE, in my Visual Studio codes, because I have some existing projects. That's why we've got the signals. Okay, let's go on with the same stuff. Let's do it here, and let's do the same stuff there. Okay, so below we have a disabled button, or a button that might be disabled. And for this, we are looking into from and to, and when at least one of them is empty, then we disable the button. Also here we need the getter. And also here, when accessing the flights array, we need the getter. When accessing the basket, we need the getter too, and this is the return of the turtle. I think it's called the Cooper, isn't it? Cooper Trooper. Okay, so we do the same with the basket, and now Bob should be our uncle. Let's check this. Let's go into the application. Oh yeah, I messed up. I've data bound the contents of a function, which is my signal. We need parentheses. I cannot say it often enough. We need parentheses to access the value. But now Bob is our uncle. I can search for flights and I find some flights. Awesome. Awesome. And perhaps you say now, yeah, this looks well. However, honestly, Manfred is now implementing stuff for 20 minutes and still the application is doing the same as it did in the beginning. So why is all of this beneficial? And the answer is, well, the benefit of this is we now have a reactive system. a reactive system that allows us to speed up change detection, because now change detection can find out where changes have been, and we can immediately react upon changes. We can immediately search for stuff when the user enters something here. Let's get started with the first point, namely with improving change detection performance. For this, I'm switching to my flight card component. And here I'm doing something that is really ugly. I'm data binding my blink method. Blink is doing what the name tells us. It makes the flight card blink. Normally, you should not do this. Normally, you should not data bind methods that do a bit more than a traditional getter, because this might slow down change detection. This method needs to be executed time and again. However, here I'm doing this on purpose because I want to visualize when and how often change detection kicks in. So let's have a look to the application. Let's search for flights and blink. Obviously, everything is blinking because we just got data from the backend. This data needs to be data bound, and yeah, so our changes are put into the cards. Makes a lot of sense. But now, when we start typing something into the field here, with each and every keystroke, my cards begin blinking. If I change to another field, everything is blinking. If I click delay first flight, everything is blinking, even though I'm only changing the first flight from 13 minutes after midnight to 28 minutes to 43 minutes to 58 minutes to 1:13 and so on. The other flights remain the same. And even though only one flight is changed, everything blinks. This is what Angular does by default. It just wants to be on the safe side, and so it checks everything for changes after an event handler run. But now we can improve this, and for this I want to switch to the improved data binding strategy called on push. You might know it, change detection, Honda on push. And we do the same here. And that's it. So now let's check the application again. I'm searching for flights, and obviously everything is blinking. Makes a lot of sense because we received fresh data that needs to be data bound. But now when we start typing something into this text box, nothing blinks. And when I change over here, also nothing blinks. So it's more performant. Seems like Angular found out that there is no need to update the flight cards. But look now when I'm clicking on delay first flight, my application is broken. It's broken, but fast. Yeah, being fast was the goal, so we should be happy, shouldn't we? No, of course not. We want to have both. We want to have a working application and an application that is fast. So let's think twice why this is broken now. The answer for this is found in my flight search component. To be more precise, in its delay method, because delay is mutating the flight in question. However, in on push mode, Angular is not checking if one of the properties has been mutated. This would be too much effort. Instead, it is just checking if the object reference was updated, if the memory address is still the same, or if there is a new object. Or to put it in another way, we need to go with immutables. Immutable objects that are not changed, instead of changing them, they are exchanged by other objects with the new values. This easily allows Angular to find out where a change have occurred and which of the child components here, which of the flight cards have been affected by this change. Okay, let's go with immutables. It's not that hard. I can use flights.update. And now update also gets the contents of the signal, and we can use it to project the contents to a new content. Here I'm doing nothing at all. I'm projecting flights to flights. Here, I would just go with a clone. I would clone my array. A shallow clone, a shallow copy. And yeah, this is partially what I want to have. I want to clone everything, starting with index position 1. But when it comes to index position 0, I want to clone in my former flight from position 0, and I want to exchange the date.
Excuse me, can you repeat in Polish?
No, I cannot repeat in Polish.
Okay, okay.
I'm very sorry. I can try in English, in German English, and in Austrian German.
Mhm.
But the thing is, we want to clone everything. We need new object references when it's about going with on-bush. So where is my new date? Oh, it's this one, date to isostring, I guess. So now my object is not mutated, it's exchanged by another object with a new memory address. And this should be good enough. This should be good enough. I'm clicking on search. I'm clicking delay first flight, and hey, only the affected card is updated. How nice is that? How nice is that? So now we have a more fine-grained change detection, but as we will see in one of the last discussions of today, it will be even more fine-grained when signals allow us to only update a portion of our components. Here, at least, only the affected component is updated. Okay, as mentioned before, having a reactive system helps us to improve data binding performance. And by the way, signals help here because the signal tells Angular, hey, this array has changed. And because we have immutables, we can find out which of the flights in this array have changed. And then Angular is only checking the affected flight cards, the affected subcomponents. That means in the past, when going with on-bush, we used an observable with an async pipe plus immutables. Nowadays, beginning with Angular 16, we can use signals together with immutables. And as an alternative, we could also use nested signals. Somehow we need to find out what or which of the subcomponents have been affected by a change. This can happen by looking at object references or by looking at nested signals. Currently, working with nested signals is quite difficult. I guess we need some tooling support for this. Tinkering a nested structure with signals by hand somehow feels weird. And that's why I think stores like stores for state management, NGRX, and so on, will become more important when we switch over to signals. The NGRX team is even working on a very own signal store. Besides this, they are also updating the existing stores so that they also work with signals, not only with observables, but also with signals. And yeah, all the other vendors of stores like RX Angular or NGRX are also thinking about bringing in support for signals. Actually, they are not just thinking about it. There are some RFCs and they are discussing it, and some of them already implemented some prototypes. Okay, so this was the first benefit. It's about performance. The second benefit is now we have a reactive system that allows us to directly react upon changes. So let's try this out. For this, let's move into our flight search component. And here, let's create a calculated signal. Let's call it flight route. It's a calculated signal using from and do. And the nice thing about calculated signals is this calculation is executed once, and then only again when one of those value changes. That means computed is registering for this and that value, and when one of those values changes, then it will be recomputed. It works a bit like selectors in NGRX or a bit like pipes in Angular. It is using memorization. The last value is memorized, and it knows when it's time to recompute the value. So let's try this out. Let's go to the flight search component. Let's data bind it here. I'm misusing H3. I'm very sorry. Hamburg, Graz. And now when I'm changing it, the output will be updated immediately. Of course, this is not in the sense of the inventor to have an effect like this, but even though I think this is the easiest example to show how those computed properties work. Besides having computed properties, there is another building block in signals, namely effects. Effects like side effects. For this, let me introduce a constructor. Let's go with an effect.
Is it Python?
Sorry?
Is it Python?
I didn't hear you. I'm sorry.
Because it's application Python. Is it it?
No, it's Angular.
It's Angular.
Okay.
Angular.
Okay, effect. And the nice thing is, if we call now a signal in here or a function or a method using a signal like search, then first of all, this function is executed. And then the effect is registering with all the used signals. And when one of those signals changes, this effect is re-executed. That means this is now enough code for triggering a search every time we change one of the values. So let's switch to New York. And yeah, we see we get New York, Graz. We can now fly from New York to the metropolis of Graz. Or I don't know, do we have San Francisco? No San Francisco. Yeah, we have San Francisco. What we also see is we don't have a debouncing. We are triggering the search method immediately when we change something. And debouncing is one of the nice features we almost get for free when working with RxJS. And that's why we will introduce RxJS in some minutes to get this debouncing. We will combine RxJS with signals. There is a bridging possibility, Interop package. But before we do this, before we go with RxJS, let's go with another effect. Let's go with an effect that is printing out the current flight route. Console log flight route is dot flight route. And obviously you won't be that surprised. Now every time my flight route is changing, I get a value print out to the console. Here and there, and so on and so forth. So perhaps I should tell my interceptors to not write out that much stuff so that we can focus on this console output. Just give me a second. Interceptor, we will work without you in the future. This was the first interceptor, and I think the second one is here in flight booking. Ah, looks good, looks good. Okay, one more time. Yeah, now we can really focus on this console output. So every time we change the input, of course, the effect kicks in and writes out the current flight route. This is nothing I would call home about. However, this allows us to investigate another nice feature of signals, a guarantee, as they call it. This guarantee is called glitch-freeness. So in this case, we need to know what's a glitch. Well, let's assume we start with Hamburg, Graz. Hamburg in Germany, Graz, the huge metropolis in Austria. And then after starting with Hamburg, Graz, let's say after 2 seconds, we switch to different airports like Paris, London. Okay, so normally we would now get started with Hamburg, Graz. And then after we set from to Paris for just a tiny amount of time, we would have Paris, Graz. We here have the new value, we still have the old value for from. And this is considered to be a glitch, an accident. And only when the second setter run, we get Paris, London. So the thing is, with RxJS, we would have this glitch. It's natural in RxJS because RxJS is event-based. That means here we have 2 events. The first one is changing from, the second one is changing to. With signals, we do not have this glitch. Signals is doing everything at once, and only then all the signals are notified. There are 2 phases. First of all, we have the updates, and then we have the notifications. This is very important because we don't want to trigger change detection after each and every little tiny setter call. If it happens in the same stack frame, then it will happen at once, and only then all the other signals and also the UI is updated. Makes more sense for values that are set and changed over time. It does not make that much sense for events. That's why we have glitches with RxJS. We don't have them with signals. So let me prove this. Let me reload the website, and here we see Hamburg, Graz. And after 2 seconds, we see Paris, London. We don't see this intermediate result of Paris, Graz. No glitches with signals. Little tiny, but a very important aspect. By the way, before we move on, meanwhile, we have signals, meanwhile, we have standalone components, meanwhile, we have a lot of other improvements that make Angular more lightweight. And so why not make this call here more lightweight? In theory, as we have signals now, we could do this call just with promises, async and await. especially if you don't need the power of RxJS operators. If you don't need the possibility to cancel an existing call, async and await is your friend. It's simpler, it's more straightforward, at least if you ask me. So for this, let me introduce a wrapper. Let's call it find promise from to urgent. And let's call find in here from to urgent. And to get a promise out of our observable, I'm calling first value from, which is the operator that makes a promise out of a signal. So the result should be a promise of blind array, I suppose. And because we now have a promise, we can now totally go with async and await. I can await this method. I can take the result and put the result into my signal. And of course, if you say A, you need to say B. If you say await, you need to say async. And then it's not a void anymore. Okay, so if you ask me, this is a bit more straightforward. Of course, we don't have the power of RxJS, but perhaps if you don't need this power, then going with a simplified solution is not that bad. Okay, before I told you sometimes we want to have the power of RxJS. When it comes to triggering search after a keystroke, perhaps we want to have a debouncing. And this is exactly where the interop between signals and Rx comes into play. There is a little tiny but effective interop layer between those two worlds. It's this package here, Angular Core RxJS Interop. And basically, it gives you three functions. It gives you a function to observable that converts a signal to an observable. It gives you a function to signal that converts an observable into a signal. And it gives you this convenience function, take until destroyed. It's like a take until that is notified when the current context, for instance, the current component is destroyed. So this simplifies the implementation of this pattern. Let's make use of this. First of all, for this demonstration, I want to convert my signals from and to into respective observables. To observable from. And here IntelliSense does not work. That's why we need to import it by hand. Import from Angular for Rx Interop to observable to signal. Here we go with to observable. We are passing in from and we are getting back from $, which is, as you see here, an observable of string. Observable of string. This is what we wanted to have, isn't it? So let's go on with to observable, this.to. And here also we get an observable of string. And now we can work with it. We can do stuff with it. The typically RxJS magic. We can say, well, there is an observable criteria toller, and criteria toller is using combine latest with from and to. And then we are doing some piping magic. namely debouncing, debounce time. Let's wait for 300 milliseconds until we do something. Or perhaps we should do a filter. I only want to go on when two things are there, namely at least 3 characters for from, and at least 3 characters for to. And that's it. Now we even could convert criteria dollar back to a signal. It's up to you if you want to use it as an observable or if you want to use it as a signal. I want to use it as a signal. So let's create a variable called criteria. It's to signal this criteria dollar. And now the return value is, look at this, signal of from do or undefined. Or undefined. And now you might wonder, why do we have this undefined? This undefined option is always annoying, isn't it? Because we need to respect it before we use it. We need to check for it. The compiler is giving us a hard time in strict mode. So why did we get undefined? Well, the reason is observable does not necessarily give you a value immediately. Observables represent a value over time. And perhaps at the beginning, we don't have any value. However, a signal always has a value. That means we need a start value, and so we get undefined. If you don't want to deal with undefined, there are 2 solutions. The first solution is we can use the option initial value with our most favorite cities. Now we have an initial value, and so the return value is signal of from do or of from do, so ignore the rest. This is the first possibility, no undefined anymore. The second possibility is to say require sync. This means our observable is a synchronous one. It will immediately return a value. This might be the case if we talk about a behavior subject. This might be the case if we go with start with. This might be the case when you go with some state management solution and if you initialize your values in a proper way. Then you can say, well, it immediately gives us a meaningful value beyond undefined and null, of course. Here I'm going with my default values. Okay, let's make use of this criteria. I'm going to use it in search. C equals criteria. Let's unwrap it. Let's check for the values. Let's also not forget about this. And one more time, Bob's our uncle. Now we should have the best of both worlds. After each and every check, automatically search is triggered. However, as we only use the criteria here, we get filtering and debouncing. Best of both worlds. Okay, let's try it out. I want to go back to San Francisco. And yeah, after a debouncing, we get San Francisco. Let's talk about New York. Yeah, we have a filter, nothing happens. 2 letters are too less. However, if I type in a bit more, and if I stop typing, nothing happens. I think I screwed it up. So one more time. No, New York, London, come on. What's with New York, Graz? Yeah, okay. So if the data is right, then it works. One more time. Yeah, unbouncing works. Look at the blinking effect. Nothing is searched, but after 3 milliseconds, yeah. After the debouncing, we get an HTTP request. Let's go back to Hamburg, 123, debouncing, and we have Hamburg. Okay, nice. Best of both worlds. Another experiment I want to do with you is I want to find out how long those observables live. Because, you know, it's always a pain. We need to close observables, we need to unsubscribe from them, otherwise we can end up with memory leaks. So let's have a look how this works here with observables and signals. For this, I'm doing something that's a bit special. I'm going with an additional dummy value, and this dummy value gets an interval. And of course, now I need a starting value for my dummy. Also, let's create an effect that is just printing out the dummy value, the counter, to the console. This criteria dummy. Okay, let's have a look what happens here. Yeah, it's counting up. JavaScript is really good at counting, and math in general, yeah. But when we move away, it stops counting. Look at this. We moved away and immediately it stopped counting. Let's go back and it starts counting again. -1, 0, 1, 2, 3, and so on and so forth. If we move away, it stops counting. So this is the default behavior of signals. You don't need to unsubscribe from signals. Angular is doing it for you automatically. A signal is automatically destroyed with its very own context. If the signal is used within a component, like here, then this here is the component's lifetime is the lifetime of this subscription to the signal. If we do the same in a service, then the lifetime of the service defines the lifetime of the usage of the signal. For instance, if it is a global service for root, then the signal will obviously live forever. If the service is instantiated on a component level, then it will live as long as the component itself. And that's a good message, isn't it? Signals are automatically unsubscribed. We don't need to take care about this. Saying this effect here is more or less subscribing to the signal. This effect here, but also using the signal in the template is like subscribing to it. Okay, this is the story with signals. But now the big question is, what's with observables created on top of signals? Good question, isn't it? Well, let's try it out. Let's step in here just for didactical reasons. Don't do this at home. Let's subscribe in the constructor. This dot criteria. Subscribe. It's counting, yeah. Dummy 2, dummy 3, dummy 4, and so on and so forth. And now let's move away. And it's going on. My observable goes on. You know the Titanic song, I already hear it. My observable goes on. And yeah, this is the behavior we get. the Angular team did not want to change the semantics of the observable, because people that know about observables would not assume that an observable is automatically unsubscribed from. That's why we get this auto unsubscribe feature with signals, but not with observables. However, if we want to have the same feature with observables, we could use the third function that comes with our Interop package, take until destroyed. And then we would have the same effect. Then when the context is destroyed, which is the component in this case, also we are unsubscribed from criteria $. Okay, let's change this back so that we don't have a counter. No one pays us for implementing a counter. I want to have a reactive search. Okay, I have one last thing for you. Namely, one big question now might be, what does this mean for my state management? Do we even need state management? Because now we can manage state with signals. The thing is, I really think that state management will become more important because we need some source that manages our signals. Perhaps we even need a source giving us nested signals. And the good message is, it's really simple to adopt existing state management solutions to signals by using those functions here, functions like toSignal. Plus, as mentioned before, most vendors are going to implement first-class support for signals in their store solutions. And the NGRX team is even working on their very own signal store. So let me demonstrate all of this. For this, I want to inject my NGRX store. And then I can say, well, flights now comes from the store. Select flights, select flights. And of course, this gives us an observable of flights. However, we want to work with signals. So let's go with toSignal. Now, as discussed before, we get a signal of flight array or undefined. We don't like undefined, but here we are lucky. We have a store and we know the store is using behavior subjects underneath the covers. If they are properly initialized, we have an initial value. So let's go with require sync true. And now we have our signal of flight array. We also need to trigger the store somehow. We need to dispatch an action, but this is, as always, there is not really a change here. Just say, hey, store, I want to dispatch an action. It's called load flights. And I have a from criteria and a to criteria. And that's it. By the way, the big NGRX store I'm using here, I'm just referring to it as the big NGRX store to distinguish it from the component store and the upcoming signal store. This big NGRX store will get a convenience function that will be called select signal. So in this case, it's even less effort to write this. But until we've got this, we can totally go with toSignal. Okay, let's try out if it works. Nothing works. Oh yeah, we cannot update our stuff here. I have this delay function. I also need to trigger an action here for delaying my flight, but that's not such a big deal. I just need the ID of the flight in question. Flights at position 0 ID. And then I tell the store, please dispatch an action, delay flight. Here you have the ID. Okay, flights, search. And if I change something, let's say now I want to go to San Francisco, San, and it works. Awesome. How cool is that? Okay, that means we get a reactive system. We get a very simple building block, namely signals, to build such a reactive system. We have seen all the features signal provides. You can set a value, you can get a value, you can be notified. You have side effects and computed signals. That's it. So it's really a very simple building block. Plus, this allows us to speed up the change detection and to write reactive UI experiences. And if we want, we can combine it with the power of Rx. So let me give you an outlook to a quite new feature that will come up in the near future after Angular 16, namely signal components. It will be a new type of component. At first glance, it looks like an ordinary component. However, the current CFP tells us that we need to set signals to true to make a signal component out of it. And if we have such a signal component, everything that we want to data bind needs to be a signal. We don't need Zone.js anymore, because now everything is a signal. Plus we get partial updates of our components. We get a fine-grained update of our components. Currently, in Angular 16, signals can be used as an observable replacement. But in Angular 16, still with onPush, we get updates on a component level. Here, in the future, with signal-based components, we can just update a little tiny fraction of our component. This little tiny fraction is always a template, which is in this sense the contents of a structural directive. If ng4, perhaps someone gives us an ng update this when changed. Would be possible. Some people proposed an ng let for this. Another aspect of signal components is we get a refreshed API, especially when it comes to decorators on a property level. They are replaced by functions like this here. That means instead of add input, we just say property name equals input. This gives us an input, and this input, this property, will be represented as a signal. So we can directly react on changes when the parent sends down new values. The signals here on the class level will stick, but also for this, the Angular team is discussing alternatives. But you know, alternatives in a very, very, very backwards compatible way. And here, for this new API, we will get functions. So why do we need signal-based components? Well, they allow to completely work without Zone.js. However, they work together with traditional components. And this is important, especially for huge enterprise scale applications, because that means we don't need to rewrite existing code. Everything that is there will still work. But if we want, we can use the new API for new stuff or for new projects. So everything will work. However, if we want to get rid of Zone.js, we need to migrate to signal-based components. In my opinion, people will have a mixture in the beginning, and I think they will just go with signal-based components when they start a new project. This is what we need. Moving over to new innovative stuff, little by little, step by step. No big bang migration, no huge breaking changes. Yeah, this also gives us a fine-grained change detection, which means that only a portion of the component can be updated. And one more time, you don't need to hurry and worry. You don't need to update your existing code. Everything still works. We will have Interop. So let me come to a conclusion. What did we see today? Well, we saw that signals allow for a fine-grained change detection. We saw that the future is zoneless, which will be possible on top of signal-based components. Also, we still can convert signals to observers and vice versa. That means we can use the simple API of signals together with the power of Rx. No need to unsubscribe. That's quite a nice aspect. And no need to update code. I cannot say it often enough. And that's it. Now I would say let's go on with the Q&A. And before we go on with the Q&A, I have a little tiny information for you, namely this good-looking, young, sportive man, which is of course a lie, will do an architecture workshop, an Angular architecture workshop. And in his 2023 version, he also will address signals. It's a video course. That means you can learn when you have time, everywhere you want, in your very own pace. There are recordings, there are labs. The labs guide you through all the exercises. And there are office hours. That means once a week we meet live via Zoom, and there we can discuss all your questions. And honestly, I really love this setting because in this case, our energy, our live discussions are very concise. In these office hours, we really talk about exciting things or about your showstoppers. We don't need to discuss regular theory. All of this is done in the videos and in the exercises. So it's one possibility to use the time you have as good as possible. Yeah, I think Darek can say something about the sales period. I think it's until the end of the month. You can buy it.
Yeah, exactly. We have a very special price. So we started the new edition of this Angular architecture video course. So from today to the end of the month, we have a very special price. And Manfred promised to add new materials. You can say a few words about that.
Pleasure, yeah. Let's talk about the material. So buy it now. Time is ticking, or the clock is ticking. Yeah, it's about general purpose ideas like domain-driven design and how to implement it with an NX monorepo. It's about micro frontends with module federation. It's about Angular elements. We talk about a lot of architectural topics like implementing your strategic design, which is a theory of domain-driven design with NX, how to visualize your architecture, how to categorize your libraries and enforce your specifications. We also talk about module federation and dynamic module federation for micro frontends and so on. There are a lot of topics. We even talk about modern authentication scenarios with gateways, the latest recommendations of the OAuth2 working group and micro frontends. We talk about mixing different versions and frameworks. And here we have the two new topics. We will have a look at all the innovations of Angular. We got some cool innovations with the last versions, with version 15 and 16, like standalone components and like standalone APIs, functional guards, resolvers, interceptors. We will have a look at them. and find out how to use them for a very lightweight and modern architecture. And we do the same with state management and the brand new signals. This will also be one of the parts in there. Yeah, so much about a slide overview of the topics. There are some bonus chapters, so feel free to check out this page. It's angularmaster.dev.
Exactly. So now we can switch to the Q&A session.
Yeah, pleasure. So who has questions?
Yeah, hi Manfred.
Hi.
So, can we use signals in a service like behavior subjects inside a service, or the signals are bounded to components only?
You can really use signals everywhere. So they are not bound to a specific building block. You can use them everywhere. You can use them in a service and a component. You can even use them as a exported constant on a module level. So you are free to go here.
Thank you. Yeah, that's all.
Very welcome. Michael is asking, can you narrow down the effect callback to be fired only when a particular signal is changed? Yeah, that's possible. So to shortcut it a bit, before I told you the effect is always triggered when one of the signals changes. However, you could say, I don't care about a specific signal. There is a helper function. It's called, I think, without tracking. Don't shoot me. Perhaps it's a slightly different name, but there is such a helper function. And if you use the signal together with this helper function, then this signal is not tracked within this effect. That means if the signal changes, the effect is not triggered. This allows you to implement something like with latest from, where you combine two data streams and where only one stream is the driving one, the other stream is the passive one. Are there any further questions?
Silent. Okay, so if we don't have any more questions, Manfred, thank you. Thank you so much for today's webinar. It was a pleasure, as always, to host you. And
yeah, same-wise. Thanks for having me.
And yeah, so everybody, thank you very much for joining us today on YouTube, on Zoom. And yeah, see you next time. Thank you so much.
See you around.
We have
Bye.
one more question.
Oh, yeah.
Moment.
Oh, yeah, now I see it. How do those signals know about the component? Well, the thing is, the signals themselves don't know about the component. However, the signals are used in an effect within the component. It could be an explicit effect like this here, or an implicit effect where you do just data binding to the signal in the template. And this effect knows about the component. Finally, this effect is only allowed within the initialization context. Most of the times you will use it within the constructor or for a default value of a property. Because this initialization context allows the effect to use inject. And inject allows us to get a, I'm not completely sure how it's called. I think it's the destroy context or yeah, something like this. Don't shoot me. I'm not really good at remembering names, but it's a service that tells us when the lifetime of the current building block is over. In this case, the lifetime of this very component. So the signal does not know, but the effect knows. That's the answer.
Okay, so one more time, thank you so much. And if you want to learn more about signals, I invite you to listen our last podcast with Manfred, where Manfred talked a lot about some specific things regarding signals. The podcast is Angular Master Podcast. You can find it on every podcast platform. Yeah, so I highly recommend it. And yeah, thank you so much. Thank you, Manfred. Thank you, everybody.
Thank you. Bye.
Bye-bye.